All right, here we go, you guys. So this is normal distributions, example 10C. We have a young lady who's taken the SAT, which we are told is normally distributed with a mean of 998. Her name is Andy. We call her Andy. Her full name is Andrea. We'll talk about her a little bit more later. But anyway, she scored 1,466 on the SAT. Now, look, Mr. Soggy Bottom is kind of throwing some things out there to check if you can understand what kind of question we're dealing with. We're given a score, 1466. All right, this is the same type of question we were doing earlier. But if they want to know what her percentile was, wouldn't that be the percentage of people who scored below her score? So visually, that would be this area here shaded forever to the left below her score. All right, so this is actually the kind of question that we were doing earlier. So her percentile would be that percentage, that probability that falls, all scores that fall below hers. All right, so what percentage of all the scores fall below her score? That's a percentile. All right, so now we're back to, I'll give you a score, I'll give you an X. You tell me the percentage that relates to it. And again, percentile would be what's the percentage of scores that fall below her particular value. So here we go. We're looking at what percentage of scores where the Z is less than something. Now, we need to figure out what her Z score was. All right, so that we can use that table there. And here we go again. The key to that is to standardize her score with that little translator there. So we'll come over here and we'll say, all right, her Z-score would be X 1466 minus mu 998 over sigma 202. All right, pop that in a calculator here. 1466 minus 998 equal it out. Don't hit the divide yet. And then take that 468 for the record and divide that by 202, and that would tell you that her Z-score was 2.32. Again, we round that to 2 decimal places. I see 2.316, 16 would round to 2. All right, be very careful with that. Make sure you round according to the normal rules of rounding. So actually, her Z-score is 2.32, positive. Yes, she's above the mean. That should come out to be a positive number. So we go, all right, we got us a Z-score. Looks to me like now we'd be able to come over here and take a look at this and table time. All right, and when we go to that, I'm out of breath, aren't you? This is a good workout though, all right? Anyway, 2.32 gives us 0.4898. Now, we got to remember, though, that 0.4898 is only that region from here to the middle. Table always give middle sliver, all right? So that doesn't mean that she's at the 49th percentile. Her score, that gets you back to the middle. But wasn't her score also above all these 50% down here, right? It's there to the middle plus another 50%. So it looks to me like if we would take that 0.5 and add 0.4898 to it, she would get 0.9898 or 98.98%. All right, now, any of these I'd probably accept. But just to put it in the full context of the way the question was worded, and let's go back to the question again, okay? The question was, what was her percentile? So why don't we put it into that context here? I would say, and when you talk about percentiles, you typically round to the nearest whole percentage. So that's, look, that's almost 99% in it. So I would say percentile 99, that's good enough. But let's even put the fact that that equaled her score of 1466 To me, that seems to be the best way to completely give the answer. So this young lady's really smart. Her score on that SAT was higher than 99% of all the others who took the test. And as I mentioned earlier, who's Andy? That would be my daughter Andrea. And so, you know, I guess I'd just throw out there that all that work on the chalkboard out in the garage back when she was in grade school really paid off here. I'm really proud of you, Andy. She's now in graduate school and doing really well. And I'm just grateful that she took after her mother and can score at the 99th percentile like this. Because, you know, I don't know if I helped much when it came to the gene pool here. But anyway, I love you, sweetie. I'll see you later, numerator. After a while, percentile.